Hi, welcome to this Blender video tutorial entitled MetaObjects, Object Mode Controls. Blender provides modelers with a series of primitive objects called MetaObjects. Unlike most Blender objects, MetaObjects are implicit surfaces. This means that they are not explicitly defined by vertices, edges, and faces, such as mesh objects are, or by control vertices, such as nerve surfaces are. Instead, they exist procedurally. Meta-objects are literally mathematical formulas that are calculated on the fly by Blender and expressed as three-dimensional surfaces. Because meta-objects require a substantial amount of computer processing power to calculate on the fly, they received rather minor attention from modelers when they were first introduced into the Blender toolset. However, most modern computers have such a large CPU capacity that they can now be a regular part of the 3D modeling arsenal. To demonstrate meta-objects, I have a blank Blender scene displayed in top orthographic view. I'll press Shift-A and add a metaball ball object to the scene. The metaball object is displayed as a rather rough sphere. I'll press the Z key to go into wireframe display. This reveals the underlying calculated mesh. Notice that the metaball has a ring surrounding the object and that ring is omnipresent no matter how the object is viewed. This ring is called a selection ring, and it's used to select an individual meta-object. All Blender meta-objects have a similar selection ring. The ring is black when the meta-object is unselected, and yellow when the meta-object is selected. I'll place my 3D cursor to the side, and I'll add another metaball ball object to the scene. I'll press the A key to deselect the object. Notice that I can right-click on the first metaball object and select it. When I do, the first metaball object is selected, but it also activates the underlying calculated mesh of the second metaball object. Also, I cannot select the second metaball object by right-clicking on the underlying calculated mesh. The method of selecting metaball objects is to right-click on the selection ring. Here I will right-click the second metaball selection ring to select it. Then right-click the first metaball selection ring to select that object. I'll press the A key to deselect the objects, and use the box select to select both of the meta-objects. Then press the A key to deselect both objects. The reason for this unusual selection method is because as you add more meta-objects to your scene, Blender creates what they refer to as a family of meta-objects. Note the key object is called mball, and the second meta-object is called mball.001. I'll add a third meta-object to the scene, this time a metaball capsule object. Note that the name of this object is mball.002. The metaball capsule is part of the family of meta-objects. I'll select the first metaball object and go to the Object Data Editor. Here in the metaball panel are a number of different controllers that affects the whole family of meta-objects. Note that currently I am still in object mode. These metaball panel controllers are global controllers operating on all objects in the family of meta-objects. I'll press the Z key to go back into solid shading display. The most unique feature of meta-object is how they interact with one another. I'll select the first metaball object and move it progressively closer to the second metaball object. Note that as I do, the two meta-objects are attracted to one another and stretch their calculated mesh surface to connect with one another. I'll select the second metaball object by right-clicking on its selection ring and do the same thing. Remember again that this is all being done while the object is in object mode. I'll select the third meta-object and do the same thing. The influence area two meta-objects of the same family have for one another is controlled by the threshold controller in the metaball panel. This threshold controller is a global control for all meta-objects belonging to the same family of meta-objects. This influence area is not as clear-cut as might be expected. It might be thought of more as a surface area of influence. Each type of meta-object creates an implicit surface based on an original structure. The metaball's object's original structure is a point upon which it creates an isotopic or all-directional field surface. The metacapsule object's original structure is a line upon which it creates a closed cylindrical field surface. As I increase the threshold setting for the family of meta-objects, the objects decrease their field surface toward their original structure. Thus, as I increase the threshold setting, the metaball becomes more and more like a point, and the metacapsule becomes more and more like a line. As I decrease the threshold setting, the field surface grows, and thus more of the meta-object constructed surface is available for the attraction to other meta-objects. Here I will set the threshold for this family at 0.2. The resolution setting in the metaball panel, which is also a global setting for the family of meta-objects, controls the display and render resolution. Lowering the setting makes the resolution of the displayed or rendered meta-object fine and less faceted. This view resolution essentially controls the density of the underlying calculated mesh. I'll press the Z key and go into wireframe view, and adjust the resolution down to make the resolution finer or more dense. Then I'll raise the resolution setting to make the resolution more faceted and less dense. One important note here is that the wireframe view resolution accurately depicts the mesh density if one converts a meta-object to a mesh object. I'll set the view resolution to 0.2. The Update Always, Half, Fast, and Never buttons allow some flexibility in how the 3D display is calculated, but most modern computers are fast enough to use the default Update Always setting. However, if you create a very complex model with many meta-objects at a fine resolution, you may find that your computer is slowing down, and you might then consider using some of these display options. Meta-objects can be moved, rotated, or scaled. They can also be scaled along a particular axis. For instance, here I will press the S key, followed by the X key, and scale this metaball down along the Z axis, and rotate it. Then move it into the other meta object. I will select the other meta capsule by right-clicking its selection ring and scale it down a bit. Then rotate it and move it under the metaball object. I'll go to Side View. I'll select all of the meta objects and rotate them. I'll select the center metaball and scale it down along the y-axis. I'll select the center metaball, press Shift-D to duplicate it, and move it out to the side a bit and scale it down. I'll then make a duplicate of that and move it to the side. Meta objects can have materials and textures applied to them. However, the material or texture is applied to the whole family of meta objects, and the material or texture must be applied to the key or first meta object in the family. Here I will select the first metaball object and add a new red material. I'll then go to the texture editor and add a new texture. I'll change the type to image or movie. I'll then click on the Open button and select the gold foil PNG image on my desktop. In the Mapping panel, I'll select the Generated Cube Projection and then render the scene. Blender MetaObjects do not have a self-generated UV mapping like NURB surfaces, nor can they be unwrapped and edited in the UV image editor. However, MetaObjects can be converted to mesh objects. I'll go back to the 3D viewport, and with the first MetaObject selected, press Alt-C and convert the MetaObject family of MetaObjects to a mesh object. I can now tab into Edit mode and have access to the mesh vertices, edges, and faces. I'll delete this object and go to Top Orthographic View. I'll then add a Metaball Capsule object to the scene. I'll place my 3D cursor to the side and add a Metaball object to the scene. I'll place my 3D cursor below this and add another Metaball to the scene. Notice that the name of the first object, the Metaball Capsule, is named M-Ball. The second object is named M-Ball.001, and the third is named M-Ball.002. These three meta-objects are part of the same family and can interact with one another. I'll select the third meta-object and change its name to MBallX. I'll then press Shift-D and make a duplicate object and move it to the side. Note that this duplicate object is named MBallX.001. We now have two families of meta-objects, MBall and MBallX. The two Metaball objects can interact with one another. The two MBallX objects can interact with one another. But objects of different families of meta-objects cannot interact. Note that in order to make a second or successive family of meta-objects, you must first add a meta-object to the scene, rename it, and then make duplicate copies of the meta-object using the Shift-D command or using the Duplicate Objects button located in the left tool panel. Creating families of meta-objects is a good way to control multiple meta-objects and their effect upon other meta-objects, and in isolating them for materials or texturing.